Hello, this is Jennifer Hunley, and I'm covering two problems from WebWork number 4 regarding finding the shortest distance between a point and a plane and a point and a line. So let's get started. Problem number 23 asks to find the distance d of a point Q to the plane containing a point P with normal vector n. We will need a way to find the shortest distance from the point Q to the plane. Now, to find the correct formula, it helps to remember that what we need to know to determine a plane is a point and a normal vector. If we have the equation of the plane, we can find the normal vector from that equation. In this case, visually, since we have the normal vector, we can then project PQ onto the normal vector. And I have a illustration here. So here's our point P on our plane, point Q in space, and then our normal vector n. And then what we do is we take PQ and project it onto n to get this projection, PQ onto n. Then, from what you can see here is that this projection actually represents the shortest distance from Q to the plane. Thus, the shortest distance can be represented by the magnitude of PQ onto n. Oops. Wrong one. Okay, so next we'll move on to problem number 24. Problem 24 asks to find the distance d of a point Q to a line through a point with direction vector v. We need to find the shortest distance from the point Q to the line. Which of the following formulas will correctly give the distance d of the point Q from this line? Now, to find this formula for the shortest distance, it also is helpful to recall what we know. When we have a line, we are given a point and we're given a direction vector. Again, that can be found from the parametric equation of the line in space. In this case, visually, again, we've got our point P and our direction vector V. Go back here. Okay. And we can use this visually to give us the formula that we need. Again, we're going to do a projection. So here's PQ, and we're going to project that onto V to give us our projection of PQ onto V. And so then right here, this the shortest distance from Q to the line is represented by the space between right here. And to find this component, we can actually do vector subtraction. Now, first of all, it appears here that Q stands right over the line, and obviously in space this is not necessarily going to be the case. So to find what this distance actually is, what we do is we take the projection of V onto Q, subtract PQ, and then that gives us this vector right here, shown below. I just did a little d for distance vector there. So using vector subtraction, we can represent the distance, and thus the distance can be represented by the magnitude of the difference between those two vectors. This one was a little more complicated, not as intuitive as finding the planes. I think, again, remembering that we don't have a normal vector to help guide us, so we use the subtraction instead. Okay, so with that, covered two problems regarding finding the shortest distance between a point and a plane and a point and a line. And hopefully that is helpful. Thank you.